He's a student from the Computer and Control faculty of the University in Novi as well, as we have seen 3 other presentations already. And this presentation is on a proposal of DLNA services for DTV devices, and I'm pretty sure you will explain what DLNA services talk. Yeah. Okay.
So, ladies and gentlemen, dear colleagues and Mr. Chairman, I will be presenting the paper titled "On Quality Usage of DLNA Services in DTV Devices and Implementation of Unregulated Platform." It has been mentioned already, but I will repeat it. The embedded systems today are often getting more and more processing power. It is very common to have 2 or more cores, and it's very common to have the CPU frequency about 1 GHz. So the whole spectrum of embedded devices are getting more and more features, and they're getting more powerful. And the TV sets and DTV platforms altogether are losing its top position as a multimedia center in the household. So the industry today is trying to put more and more features in DTV platforms, and one of those features is DLNA. So the DLNA defines sharing, discovery, and control of multimedia content throughout the network. It is a relatively young standard. It's 8 years old, and but it's gaining more and more popularity. It's quite popular nowadays, and more devices choose to support DLNA. It's based on the UPnP protocol, and along with it, it's based upon XML, HTTP, and TCP/IP protocol stack. So the DLNA defines several device classes, but those can be cut down to basic 4. So we have DMS devices, or digital media servers. These are the devices in the home network that provide multimedia content, video, images, audio. We have DMCs, like digital media controllers, devices that can search the network for other DLNA devices. They can fetch the content, but they can't reproduce it themselves, so they have to forward it to DMRs or digital media renderers. So devices that reproduce content they get from DMC, but they cannot discover or fetch the data themselves. And finally, we have DMV devices, or digital media players, the devices that are able to both find and reproduce the content in the home network. So the concept of DLNA in DTV platforms is not entirely new. Today you have already TV sets and set-top boxes that support DLNA, but what is relatively new is the concept of the DMS being implemented into DTV devices. So the basic idea is that the DTV platforms are usually the only devices in the household that can actually receive the DTV signal, parse it, and utilize all of it, including audio, video, teletext, TPG, and every additional data that comes with the stream. And by implementing the DMS into DTV devices, you actually enable different devices in the household network to also utilize and get that data without the signal being directly brought to them. Of course, there are limits. The limit is the actual number of tuners in the receiving device, because theoretically you need 1 extra tuner per additional client. There are 2 concepts we've thought of to implement DMS into DTV devices. The first one is something we call raw data providing. So the idea is to have DLNA clients, so DMPs or DMCs, to be able to request a specific service. They have a list of services at DMS. They can request for a specific DTV service, and then the DMS just forwards all the transfer stream packets it receives that are related to the requested service. They are just being forwarded to the client, and the client is then free to do with the packets and with the data whatever he wants and whatever he can. So this is okay, but the DLNA clients need to have some form of middleware, DTV middleware implementation if they wish to utilize the DTV specific content like PG and teletext. The other concept we thought of is DTV DNS providing pre-processed data. This means that the interface that is exposed to the client devices is a bit different. They don't have a list of services anymore. They have different data for each service. So they can, for example, request for just audio and video, or just TPG, or just teletext. And the DMS device has to provide it in DLNA approved form. So it has to be an image, video, or audio. And it has to be understandable to the end user that is using the DLNA client device. This moves the stress from the client to the server devices, but the clients are then much simpler, and they don't need the DTV middleware to present the DTV specific data to the end user. So this is a comparison of two concepts. So short, the DMS providing raw data is simple to implement, and the complete transfer stream is passed to the clients, and the clients have more flexibility to do with it what they want, but most of the clients, most of the today DLNA clients, they won't be able to utilize the whole DTV stream, and the server-to-client interface is very simple. If we use the DMS providing process data, the load on the server is much higher because of the needed processing. But the clients, on the other hand, can be much simpler, and they do not need DTV middleware implementation. The server-to-client interface is more flexible, but also more complex and has to be designed with care. We've had a chance to implement the first concept, so raw data providing, and the platform of the target platform was an Android-based set-top box with integrated DTV middleware, as well as integrated DLNA protocol stack. The DLNA protocol stack was tightly developed with the middleware and was developed for this specific purpose. So it is highly DTV middleware dependent. The appropriate API was exposed to the Java space. And since we had no way to tamper with the data between middleware and DLNA protocol stack because of the way it was implemented, this was a natural environment for developing DTV DNS with raw data providing. The application was developed in Java because we already had the API exposed, and all we had to do was to utilize the API. The DTV middleware as well as the DLNA protocol stack was realized as native libraries, and what we did was connect it with the Java space with the JNI API layer, which is a standard mechanism in Android for connecting Java space and native layer. An implementation alternative, so this is just a concept, we haven't had yet the chance to implement this. An alternative would be, of course, the DNS providing pre-processed data. So a natural environment would be, much suitable environment would be to have, unlike we had DTV middleware and DLNA stack realizing separate models, which is more common anyway, and that would allow the desired pre-processing you would have to do with data in between. So the application would have to be a client to DTV on one side and the client to DLNA protocol stack on the other side, and we'll have to route the data between them as well as to process it and shape it in a way we wish to. So the easiest and most straightforward way was to program everything in Java, which is fine but not very performance efficient because native space is, of course, it has much better performances, and you would also have to copy all the data you wish to process to get from the native space to Java space. So you would use more memory and you would do the processing much slower. So the solution to this would be to make a new native library that should act as a bridge and do all the routing, the data routing and necessary processing, but in the native space. This would keep the memory consumption to a minimum, and of course it would keep all the performance demanding work in the faster native space.
So, are there any questions in the audience? So, you mentioned in your talk that the DLNA standard is quite an old standard, like 80 years, or old is relative, I know. The JPEG standard is much older. But is the standard, is it still an active standard where people work on extensions, or are there extensions needed when you think of new services to add in the domain of DTV?
I think so. I do know that it has been developed over the years. So you used to have only these 4 device classes, then I have handheld classes added to the specification. I assume it is still being developed because the line before that develops the standard is it is made of quite companies, like I think the former is the founder is Sony, so I think it's still being developed, and I think it needs to be developed because it specifies the allowed codecs and coding video, so these things change. These things change, and it has to move with standards. What is
And are there currently DLNA compliant devices?
Yes, many. One of the most famous is the PlayStation 3 console, so it's the DLNA compliant, and then it's the DTV set of also. So there are, I think, a few 100,000 devices. I'm not sure, but it is being popular. It is expanding.
Any questions from the audience? So, we are very much in time. We are quite fast in this session. We've been getting the little delay of 5 minutes back to being 5 minutes ahead. And so, I'd like to thank all the speakers again for the excellent presentations. So, thank you.